Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to Hardware to Save a Planet. I'm very excited to be talking to Peter Reinhardt today, the CEO and co-founder of Charm Industrial. Peter and Charm are focused on carbon dioxide removal, or CDR. CDR is, of course, a big part of the climate change puzzle. In order to stay below 1.5 to 2 degrees global warming, we have to get to where we're removing something like 10 to 20 billion tons of CO2 from the atmosphere every year. And that's on top of really aggressive emissions reductions. So it's a huge undertaking. Charm Industrial and Peter have a really innovative approach that I'm excited to learn more about. So welcome, Peter. Thank you for joining.
Yeah, thanks for having me.
I'm excited to learn more about what Charm Industrial is doing and the technology you're developing. Maybe before we get into that, though, I'd love to learn more about you and your background and kind of your path to climate change. Go back to childhood, if it's relevant. What's sort of influenced you to get to this point?
Yeah, if you go all the way back, I grew up in kind of the rolling wheat fields of the Palouse in Eastern Washington in Pullman, and then moved to Seattle when I was 5, grew up in the rain there. So really, I think kind of developed like an appreciation for nature. And my mom was always pushing on me to do good in the world, and got really into math, went off to MIT, studied aerospace engineering, dropped out with my roommates and started a software company called Segment. And a bit of a rough start to that company, 1.5 years kind of flailing around, but eventually found product market fit and grew the company to about 600 people. And then we sold the company in 2020 to Twilio for a little over $3 billion. And in 2016, I had started getting interested in offsetting our emissions at Segment. We had emissions, we were emitting CO2 from power for our offices and food that we were catering and people driving and commuting to the office and flying salespeople and so forth around to meet with customers. All of that emits CO2. And we were trying to figure out how to reduce that first, but there's also a lot that you can't reduce, like the flying. And so we were trying to figure out how to remove CO2 from the atmosphere, and ended up kind of realizing that a lot of the offsets that we were buying were not doing anything, which is becoming more and more kind of common knowledge, unfortunately. And that set me down the path of eventually starting Charm in 2018 with some friends from the aerospace industry, Sean and Kelly and Kevin. And yeah, it's been a super fun ride over the last 4 years, especially the last 2.
That's pretty incredible. You didn't like the carbon offsets available, so you decided to go make ones that would do the trick.
Yeah, it took a couple of years. I mean, we spent a long time looking for good offsets, good removals, and it just didn't exist. Eventually, January 2018, I was looking at it and I was like, well, we have an interesting idea by that point of biomass gasification, sort of producing an industrial chemical in syngas and also sequestering some carbon along the way. I was like, this is an interesting idea. And there's not a lot going on in this area. Like, there's not a lot of people working here. It's a very thin frontier. And I was like, I'm running Segment. Like, this is just a bad idea. I should just set it aside. And I just couldn't let it go. I was just like, I will feel terrible for the rest of my life if I don't chase this down. And so, we decided to give it a shot. And 2 years later, my co-founder Sean had really a key breakthrough, which was that we could convert biomass into this liquid bio oil and inject that bio oil deep underground as a form of carbon removal, putting oil back where it came from, if you will. And this turns out to be a great idea. Like, it's a pretty cheap way to put carbon back underground. It's extremely permanent. It has low leakage, et cetera. And in the last 2 years, that's really taken off. We've booked something like 15,000 tons of removal now from companies like Stripe and Shopify and Microsoft. And last year, we delivered a little over 5,000 tons of removals, which, to put that in context, last year, global permanent carbon removal deliveries were 6,000 tons. So we delivered 5,400 of that.
That's incredible. I do want to get into the details of Charm. I just think this story is really interesting of getting there in the first place. So Segment was a customer data platform software company, no specific sustainability mission. And do you think you would have gotten to climate change and climate tech had it not been for wanting to offset Segment's emissions? If there had been a good solution there for offsets, would that have been it and you would have stayed in the software world? Or was this kind of always your calling, you think?
I think something in hardware was always my calling, but
Okay.
if we had found great carbon removals, we would have just bought those, and it would have been some other kind of hardware would have been. Maybe back to aerospace was originally my passion. Yeah, no, I mean, I really love being able to build things that you can hold and see and show, and software never really scratched that itch. But yeah, climate happens to be a great place to do it since there wasn't a great solution.
Mm-hmm. And how did you get hooked up with your co-founders?
They actually all worked with my wife at Planet Labs. My wife, Erika, was employee number 12 or something at Planet Labs way back in the day, right after college. And so I met all of them during that period at Planet Labs. I worked on the mechanical engineering team or electrical engineering or so on. So we stayed in touch and eventually got together as a team.
I see. So they were doing the space hardware that was your destiny, potentially. Just a quick tangent. Planet Labs makes small satellites that they use to image.
Yeah, they got the world's first fleet of nanosatellites, these small CubeSats that take a complete picture of the Earth every day at, I forget what resolution, a few meters resolution. So really amazing for kind of change analysis of the world around us.
Yeah, cool. Okay, so actually you all have sort of this aerospace background, all your founders. Interesting.
And a huge portion of the company actually is also aerospace.
Okay. Is there a connection there? Is that more coincidence? Is there something that translates well from aerospace to what you're doing?
Well, I think aerospace engineering is kind of a combination of thermal structures, electronics, control systems, all of the sort of components of building complex thermomechanical systems. The pyrolyzer, our process is a thermal mechanical process. So a lot of the fundamentals that you study in aerospace engineering or that you have to deal with in an aerospace company have a lot of overlap in terms of a lot of the fundamentals.
Mm-hmm. Charm Industrial and your solution, you've talked about it a little bit already, but what's the good high-level description?
Yeah, at Charm, our mission is to return the atmosphere to 280 parts per million CO2. We're currently at 420 or so. And the way we're doing that is by putting oil back underground. So we take waste biomass residue, stuff like corn straw or sugarcane bagasse or wheat straw or forest operation, tree thinning, all this waste biomass that's all over the world. And we cook it down into this liquid called bio-oil. And then we inject that bio-oil deep underground. And that is a carbon removal pathway because the plants absorb the CO2 out of the atmosphere. We capture that CO2 in the form of the bio-oil. And once it's underground, it actually sinks in the formation because it's very dense. And then it actually solidifies, has a lot of phenol content, and the phenols polymerize into this sort of phenolic resin and become super hard.
As opposed to CO2 gas, which would try to escape.
Yeah. So if you inject CO2, you compress it into a supercritical fluid, and then you inject it into these permeable formations. And now there are great formations. You just need cap rocks and other impermeable layers so that the CO2 kind of doesn't rise to the surface. But yeah, the CO2 is buoyant. And so physics is not totally on your side there. You then have to be pretty careful about the geology of where you're injecting. Whereas with bio-oil, because it's so dense, you don't need the same kind of protections and cap rocks and so on, because you're going to solidify.
So your customers are people like Segment looking to offset their emissions. That's the business model.
Yeah, the business model to begin is selling to companies that want to offset their emissions. It happens to be really well aligned, I think, with software or technology companies. So first customers are Stripe, payments company, Shopify, the e-commerce platform, Microsoft, Zendesk, the help desk support service, Figma, the design product, Square, also known as Block, the payments company. So lots of software and tech. Part of the reason for that is that obviously tech companies like to believe in technological solutions, but also tend to have pretty small footprints of emissions relative to their sort of total revenue and profit margin, if you will, as compared to industrials. If you're a steel manufacturer or you're drilling fossil fuel out of the ground or something like that, you're emitting a lot of tonnage of CO2 and it is not cost effective to remove. There is no world in which you're going to pay $600 a ton to put CO2 back underground if you are a steel manufacturer. It's just too expensive. And so, yeah, it's not a great fit there. And so, yeah, that's who we sell to today. We have about 40, 50 different customers. And there's been some exciting things happening in the world of buyers. Stripe Climate has evolved to be Frontier Climate, which is an advanced market commitment. So they pulled together a $925 million, almost $1 billion commitment from Stripe, Shopify, Google, Facebook, and McKinsey to purchase carbon removals and help scale up the ecosystem. So from 2 years ago, there were 0 buyers of permanent carbon removals, and now there's over $1 billion committed, maybe, and probably accelerating pretty quickly beyond that. So the demand side of the equation has really shifted a lot over the last 2 years.
Did you see that coming when you started getting into this?
I mean, certainly not in this shape, but in structure, sort of, right? Like I was trying to buy something like this and it didn't exist. And it seemed like it was necessary. So sort of out of confusion, I guess, we like, like, shouldn't this thing exist? It turns out, yes, it should. And it turns out, yes, other people are realizing the same thing. And yes, they will buy it.
Yeah.
I think voluntary purchases like that will only go so far, maybe billions, tens of billions. But beyond that, we will need policymakers to step in and create markets. Things like the low carbon fuel standard in California, which effectively creates it's a cap and trade system on refineries in the state, and carbon credits in that system trade at $100 to $200 a ton. So we'll need more markets like that to be created through policy action.
And what was wrong with the other offsets? Is it mostly natural sinks, or can you talk about that?
Yeah, and natural actually is awesome. Like it's great if there's a natural way to do it. The problem is that most of the existing offsets, nature-based or cook stoves or refrigerant destruction or what have you, soil carbon, et cetera, have very low permanence. So the carbon doesn't actually stay out of the atmosphere for very long. Low additionality, which means that whether you pay the money or not, the thing is probably going to happen anyways. And high leakage, which is, okay, even if you prevented carbon emissions in this area, it will probably just pop up somewhere else. So examples are, let's say you set aside some rainforest in the Amazon or in Indonesia, which is what we did the first year at Segment. It's not very permanent because even if you like protect that section of forest, eventually it's going to burn down in a forest fire. Or you could have like a change in regime in Indonesia and like ownership doesn't matter anymore. Or you could have a change like we have seen in Brazil, where actually there's a president now in Brazil who's like really encouraging deforestation. And that these are like exogenous risks that you can't really control just by buying the rainforest. You also have leakage in that you protected this section of forest, but like deforestation pressures still exist. And so they may just cut down the forest next to it instead of that forest. So these sorts of things are really hard to measure. And so even though it's like a beautiful concept of like we set aside rainforest and it's super important for ecosystem protection and we should do it just for the ecosystem protection, the actual carbon impact is much, much less clear. And that was the feeling that I had. And now more recently, like the scientific literature has, I would say, validated that. Like some of the most recent analysis from like Stanford, Berkeley, Oxford, like the Berkeley Carbon Trading Project found that something like 97% of the carbon offsets that are bought do nothing.
Wow.
So that 3% that remains is good, I guess, but it means you got to multiply the real price by a factor of 30 to understand what you're really buying.
Wow. And do you see that these buyers you talked about, these tech companies, are they savvy to that and willing to pay for the permanence?
That's exactly right. People have become very savvy about it over the last few years. So all of these buyers, like the reason they're looking is because they're like, wait a second, when I buy this stuff, this is greenwashing. Like I'm not actually having the carbon impact that I'm claiming. And so therefore we need to go develop real carbon removal solutions. And that means paying a really high premium for technologies that are just starting to come down the cost curve. And so that's what's motivating the Stripes of the world, the Shopifys of the world, the Microsofts of the world, et cetera.
Yeah. And when you say permanent, I mean, is there a time scale on this or is it just, it's permanent?
Usually the standard is 1,000+ years.
Okay.
I think most of the analyses of Charm are like 10,000 plus, probably millions of years, but it's a little hard to say, like a very, very, very long time.
That's a lot of years.
Yeah. Whereas a lot of nature-based stuff or forestry-based stuff is often more like 10 years, 20 years of permanence, which might help with shaving sort of the peak warming that happens over the next few decades. But it means we're going to be paying a constant ongoing tax for emissions, because when you emit a ton of CO2 in the air, it doesn't come out. It's up there permanently. So if you're going to actually truly undo that action, you need to go remove it permanently.
Maybe this is a stupid question, but you're putting bio-oil underground. Could somebody go extract it again and use it?
Yeah, it's a good question. Actually, one of the funniest tweets to me was when we announced our first delivery. Someone tweeted back, Shell announces new discovery in Oklahoma.
Yeah, exactly.
I thought that was hilarious, but no, the short answer is no. And the reason is that the bio-oil solidifies. So
okay.
It's even if you were to pump it out, it's like a friggin' nightmare.
Okay.
Also, bio-oil has very low energy content. It's about 1/3 the energy content of crude oil. So maybe if we let it cook down there for like a few million years, then it might turn into a nice high quality crude, but not in our lifetimes.
Not worth drilling out. Can you talk a little more about where the idea came from? So it's clear you identified a need and problem and went out to find it. Can you talk about the evolution of that to where you are now?
Yeah, the fundamental insight came about 2.5 years ago from my co-founder, Sean. We were trying to do biomass gasification. So we were there's a bunch of industrial processes that rely on hydrogen or syngas, which is hydrogen plus carbon monoxide, things like ammonia production, which is fertilizer, methanol production, which is plastics, hydrocracking in a refinery, hydrotreating in a refinery, steel manufacturing can be done with syngas. All of those things I just mentioned are probably like pushing 15-20% of global emissions. So all of these heavy industrial processes depend on hydrogen and syngas. And you can make hydrogen and syngas from biomass gasification, where you take biomass and you heat it up to really high temperatures and it just decomposes into syngas. So that was the original idea, is we're just going to centralize a bunch of biomass to a facility, gasify it, and boom, feed that facility. The challenge that we ran into is that the transport costs of the biomass were very high. Because when you bring that biomass to the central facility, it's really fluffy. Like biomass is just fluffy. It's very diffuse.
Because we're talking corn husks and almond shells and stuff.
Yeah, exactly. Bales of straw, basically.
Okay. Straw. Okay.
Yeah. Bales of corn straw is maybe like the most voluminous example in the US. And it's just not very dense. Like you just can't transport it very effectively, cost effectively. And it's a solid, it's blocky. So you got to have like forklifts moving around to unload it. It's like it's a pain. Every time you touch biomass, it like explodes in cost. And so that was where we were stuck. And then my co-founder, Sean, had this really interesting idea. He's like, what if we split the gasifier into 2 machines? And the first machine is out at the field and converts the biomass on the field into a liquid, bio oil. So we sort of do half-assed gasification, where we only go halfway to this liquid. Now we have a pumpable fluid that's like 10 times as dense. So this is really easy to transport. Now we transport it either by truck, by rail, by barge, whatever. And then we bring it to the central facility. And then at the central facility, we steam reform or gasify the bio oil into syngas. So same thing, we just introduced this intermediate pumpable fluid. And it turns out this is like a huge win for the economics and like everything works. So that was the fundamental insight of sort of the long-term model. And then we were trying to figure out like, how do we get to scale? And you could see that in the long-term economics, it works. But the question was, in the short term, how do we get started? What's the premium market that people will pay for when the stuff is initially expensive to produce? Weren't clear how to do that. And I started to feel like we produced some bio oil, and I started to feel like Sean was getting kind of distracted. He was like we'd made some bio oil and he was trying to figure out how to dispose of it. And I was pretty frustrated with that, to be honest. I tried not to show it, and I was like, dude, like, who cares? Like, dispose whatever, like proper disposal of bio oil is like, sure, we should solve that eventually, but like, this is not top priority. And he found a couple different disposal methods, one of which was incineration, and the other was to inject it down a well. And then I think, I don't know, a few days later or something, he was like, wait a second, if we inject it down a well, isn't that permanent carbon removal? And so we like chatted about it. And I was like, interesting. All right, well, like I'll go build we built a financial model, and we're like, wow, it's cheaper than direct air capture. That's interesting. So we went to Stripe and we were like, what do you think? Should we apply with this? Your like deadline for your first carbon removal RFP is like in 48 hours. What do you think? And they were like, yeah, please apply. Please apply. And we're like, okay. So we applied. They gave us an award for $250K to go do it, and like off to the races.
Oh, wow. That's amazing. Because that's a technique I've heard other people talking about now, but at the time that was a new insight.
Yeah. Pumping bio underground was Sean's original insight. We got a patent pending on it now, but yeah.
Oh, that's awesome. So I guess bio oil, maybe just walk through the process. You take corn straw, you heat it up. What happens?
Yeah. So we take corn straw, corn stover, that's the proper word.
Okay.
And we grind it into tiny little dust. And then we vaporize it. And when we vaporize it, we get a vapor train that has a couple things in it that we separate out. So first we separate out the char, which is like carbon and ash. That goes back on the field, improves soil nutrients, water retention, microbial little hotels, etc. Then we condense out the bio oil. That is the liquid carbon, basically carbon, hydrogen, and oxygen, but 50% carbon or so. And then we are left with the sort of non-condensable gases, which is like some stuff that we burn for emissions control and eventually will provide power to run the whole system. So those are the 3 things we get out. The bio oil itself, you should think of it as like sort of the consistency of molasses, little viscous, and has the overwhelming odor of barbecue. So like actually bio oil is the smoke flavoring in barbecue sauce.
All right.
So just imagine only the smoke flavoring, like super pungent. That's bio oil.
Okay. And I guess selling it to the smoke flavoring industry is not a massive market for you.
Correct. Yeah. I mean, it's also like a saturated market. People already do it today. You just put hickory smoke flavor.
So I guess the trade-off of bringing these pyrolyzers to the source of the biomass is that you need a lot of pyrolyzers at all of these different agricultural sites, right?
Yeah, a huge fleet of pyrolyzers. So each pyrolyzer, so we today have one sort of research and development pyrolyzer. We also are buying, we're just all about speed and trying to learn as quickly as possible. So currently we are purchasing bio-oil, waste bio-oil, and injecting it so that we can learn as much as possible about the injection, because the injection is the really weird new thing. We're also buying third-party pyrolyzers, and soon we'll be operating those. And that's so that we can learn 24/7 operation, like all the things that you need to answer for operations. Like, how do you hire people on augmented work schedules to work 24/7 shifts? What happens if someone doesn't show up for their shift? How do you do maintenance? How do you do training? How do you do insurance? Like all of those questions that need to be answered. And then we are building our own pyrolyzers as well that are fit for purpose, sort of optimized for operating in the field, maximal kind of process intensity and tonnage, et cetera. So we're doing all of those things in parallel. And the pyrolyzers that we produce will eventually operate as a huge fleet, thousands, tens of thousands, maybe even hundreds of thousands of them. And they'll be deployed much like custom harvester units. So at harvest time in the Midwest, you have combines that are operated by these groups of mostly young guys who they say have 10 combines, and they start at a field in Texas. And for a farmer, they go and harvest the whole field. And then they jump 100 miles north, drive all their equipment 100 miles north and do it again for another farmer, maybe in Texas, maybe north in Oklahoma. Then they jump another 100 miles north, all the way up to North Dakota for the wheat harvest. And then they come back for the corn harvest, do the whole thing again. And so instead of every farmer owning $1 million combine, have those combines amortized over a whole bunch of farms and a much longer period of the year where they're getting use. And so it's much more capital effective or cost effective. And we'll operate the pyrolyzers in a similar model. So roving band of carbon removing nomads, I guess, moving around to wherever the currently available biomass is and converting it into bio-oil.
And those will be operated by Charm Industrial employees?
For the foreseeable future,
Yeah. And do you buy the biomass?
We do, yeah.
Okay.
Yeah. And this is actually what's so important. When I said biomass was fluffy, maybe I should have given you some numbers of like the cost, because that's really how you can see how fluffy it is. Like if you want biomass delivered down the road, even a few miles, it's like $125 a ton. If you just want the biomass at the edge of the field, it's $65 a ton.
Oh, wow.
Cut out half the cost just by eliminating a few miles of truck transport. And then let's say that you actually don't even need it at the edge of the field. Let's say you pick it up on the field. So you get to skip the windrowing and the baling and the transport to the edge of the field. Now it's like $0 to $15 or maybe like $10 to $20 a ton.
Wow.
Then let's say that the main cost left to the farmer is nutrient replacement, putting potash back on the field because you took some potash off in the biomass. But like, remember, the char and the ash comes out of our process and we put it back on the field. So what's that value to the farmer? Probably $5 to $10 a ton. So now you're talking about $0 to $15 a ton for the biomass as it's sitting on the field if you're going to do nutrient replacement. So you like literally have like a 10 to 100x reduction in cost of the biomass by operating in this fashion. And at scale, it becomes the dominant part of the cost structure.
What does it cost to buy a ton of emission reduction or offset from Charm Industrial?
Yeah, so I'll create some of the market context too.
Yeah.
You can buy the really low quality offsets that have low permanence and additionality and leakage and so on today are available for anywhere from 50 cents to $20 a ton. Maybe even higher than that now because there's a lot of competition, maybe like $30 a ton. But for the most part, it's not doing anything. So if you want to buy high quality stuff, the price for things delivered today varies from, call it like $300 a ton, where the permanence is maybe still a little questionable, up to like $2,000 a ton for some really new methods like mineralization capture. Charm is kind of in the lower middle of that, like around $600 a ton. And the only other operating thing today is direct air capture from Climeworks, and that's about like $750 to $1,000 a ton. And then in the long run, direct air capture is kind of expected to get down to about $100 a ton. And bio-oil sequestration from Charm is expected to get down to maybe $50 a ton.
Just with economies of scale, is that the main opportunity?
Yeah, economies of scale and shifting the biomass from being delivered to being like on the field with nutrient replacement.
You said that the injection is novel. Have there been hardware challenges associated with that?
Prior to us, no one had ever injected bio-oil before. And what's odd about it is it like solidifies, it's acidic, things like that mean that you have to spend some time thinking about what's going to go on in the subsurface in terms of like target formations. Like, are you going to inject into a carbonate type formation, or are you going to inject into like a sandstone type formation, or it obviously needs to be permeable, but so on and so forth. So there's a bunch of considerations about sort of like what's your target formation. There's considerations around the construction of the well bore. Just like it's acidic. So you need steel that is like designed to be corrosion resistant. You want to make sure that your injectant, your bio oil, is not leaking out into like through the edges of the well or something, and make sure it's not leaking into any areas that have underground sources of drinking water. Super important for EPA compliance and permitting. So to do that, this is standard, but like you need a outer sheath or casing, an inner casing as well. And then you pressurize the sort of donut in between, the long donut in between with brine. And then you measure that pressure so that you know that you never have a leak in between the two casings. So anyway, all of those kinds of things go into like the well design, the formation selection, and then of course the well operation, dealing with things like solidification of the bio oil and so on. So yeah, that injection is definitely like the weirdest part of what we're doing. It's also a huge engineering challenge to build a 10-ton per day mobile pyrolyzer that can operate on field and so on. So we kind of have these dual things of like a little more researchy to some extent on the injection well side and trying to get field data as fast as possible. And then of course, like a long-term engineering challenge on building like cost-effective bio-oil production.
Mm-hmm. What would you say has been the biggest hardware challenge so far?
Maybe like an example of a hardware challenge. And like one of the reasons why we test in the field is like for our own pyrolyzers, we started building one or started designing our first 10-ton per day machine at this time last year, started construction in August, finished construction and started deployment in December to Kansas and started learning in the field early this year and learned pretty quickly that like corn stover has cobs in it.
Okay.
And cobs don't like to go through augers, at least small augers. They get jammed there. And so the team did like an amazing job of redesigning biomass conveyance systems to work with cobs. It's the sort of thing that you just like, you can't learn and you wouldn't forecast until you get out in the field and you're like, oh, well, yeah, it does have cobs in it.
Yeah.
It turns out, we were testing with wheat straw in San Francisco. And so you get to Kansas, you test with corn stover and that's just the reality. So anyway, those are the sorts of things that we're learning. That's just one funny example. But yeah.
Mm-hmm. And what do you see on the horizon? I guess from a hardware standpoint, you said building your version of a pyrolyzer is a big challenge and the injection side as well. Any specific challenges kind of looming that have risk yet to retire?
I mean, there's always risk everywhere to retire, but
yeah,
probably 75% of our engineering team is focused on, which is like 90% of the company is engineering. Of those, probably 75% of the engineering team is focused on our own pyrolyzers that are like fit for purpose to maximize like appropriate yield and production and cost effectiveness. And then the other 25% of the engineering team is focused on gasification. So once we have the bio oil centralized, can we make it into the industrially useful syngas that we mentioned before, in particular for steel manufacturing? Because then we could make fossil-free steel, which would be very exciting. Because then you would go from every ton of steel that's produced currently emits about 2 tons of CO2. And if you could flip that around and we could sequester a ton of CO2 for every ton of steel produced, that would be pretty game changing. You'd go from 8% of global emissions from steel to whatever, minus 4 to 8% of emissions. So a huge swing.
Interesting. So this would be a totally parallel revenue stream to the injection and offsets.
Yeah, we could either apply the bio oil. If you think of bio oil production as like the horizontal platform underneath, we could then either apply the bio oil to direct bio oil injection, or we could apply it first to iron making, followed by injection of the CO2 off the back of that process underground. Either way, the CO2 ends up underground, but in one, it's a little more direct. And in the other way, we indirect, but we get iron out of the side as well, fossil-free iron.
Mm-hmm. I said at the beginning of the show, and I'd be curious if you think this is the right number, but I've read that we should be removing 10 billion tons of CO2 from the atmosphere every year in order to get to this goal of limiting global warming. That's a pretty big number. And I think, what was the number we globally removed last year, you said?
Yeah, last year was 6,000 tons.
6,000.
And you're right. We need to get to about 10 billion tons by 2050 to stay under 2 degrees. And so, yeah, the industry needs to grow by a factor of 1.5 million, almost 2 million X by 2050. So it's about 65% compound growth for 28 years, twice as fast as software.
I don't know. How does that make you feel?
It means that once there's a system that works, we need to be deploying it at like wartime mobilization levels. But I don't think that the urgency for that from the public exists yet. But the bet is that by 2030, we'll probably be seeing enough of the effects in our daily lives that we might get there. And that's 2030 and beyond is when really the scaling efforts start.
that's when the scaling efforts are needed, or that's just when it's possible to get it?
I mean, in terms of I mean, that's both when it's possible, but also that's also when like the total amount of dollars necessary to deploy that much steel, and because you got to build this stuff. Like just direct air capture on its own, if it was the sole provider of that 10 billion tons, would require something like 5 or 10% of global steel production in 2050. So I mean, it's like you're talking about deploying a lot of hardware, and maybe by 2030, 2035, 2040. When we're really starting to be on an absolute dollar amount, when we're starting to be on the steep part of that curve, I think the public support to do it will be that much stronger. It's just going to get stronger every year as we keep emitting more and as we keep seeing more and more warming effects. So that's the bet.
Yeah. What do you hope Charm Industrial will look like in 10 years?
I think Charm's impact probably maxes out around like a couple billion, maybe 5, 10 billion tons of removal for the current product set. Yeah, call it 5, maybe 10 billion tons a year of removal, plus a like similar impact on steel production of like, call it 3 billion tons a year. So I think we kind of max out with the current product set around like 8 to 12 billion tons a year of potential impact. But I mean, that's a lot.
That's most of the way. I mean, that's it, right? That's a big...
Well, sorry, that's not just carbon removal. That's 12 out of the 50.
Gotcha.
That includes both reductions on the steel side and carbon removal stuff going on.
Oh, gotcha. Yeah.
But yeah, call it 12 out of the 50 is maybe the best that we could hope for, but that would be super exciting. I mean, that'd be incredibly thrilling. Yeah.
Yeah. That's an insane amount of growth from where we are today. That's exciting.
5% per year. Yeah.
Yeah.
It's hard. We'll do that.
That's cool. So I guess thinking about those numbers and knowing what it takes to get there on a scale of we're totally doomed to we're good to go. What's your perspective on kind of the future of the planet?
We're not in a good spot. We're in a tough spot. Like you draw the Gantt charts back from 2050, like we're doing with the 65% growth rate that's necessary. And like, it doesn't look great. Like it's very tight on timeline. I mean, you can do the same in the steel industry. You're like, steel is 1.8 billion tons a year of production. Only 100 tons has ever been made fossil free. That was last year, one-time delivery. This year, 0 tons will be made fossil free. So that's an even steeper curve. So, I mean, you just do that again and again. What about ammonia? What about methanol? Well, it's just like go down the whole list of all the industrial stuff. I mean, even on solar, even on renewing the grid and electric vehicles, like these are steep curves and they get steeper every year because we generally have been missing. On the flip side, like the conviction in the public gets stronger every year. And so at some point, those two curves will cross. And so I'm hopeful in that sense that like if the demand side was fixed, then we're screwed. But the demand side is not fixed. The demand side responds to like what we see in the world around us. And so I think there's hope in the sense that over the last 5 years, we've for sure seen a massive shift in the demand side. And if that trend continues, then I think we have a shot. It's also not like all humans are going to die or anything like that. It's just going to be what climate change will actually probably look like. It's a bunch of economic shocks and like economies doing more poorly than they should, and people getting like massive refugee crises as people need to move out of low-lying places like Bangladesh. Like it just looks like an unhappy, somewhat miserable world and a lot of death in ecosystems. But I think it's probably a long ways. Like I wouldn't call it like civilizational collapse or things like it's just like a lot of costs and a lower quality of living for all of our children, which is not what we want, right?
Yeah, we see a little bit of that today, and those effects, or maybe a lot of that today, but it would just be that amplified dramatically. Yeah. A couple more questions. Who is one other person or company doing something to address climate change that's inspiring you right now?
Maybe I'll call out two.
Even better.
Monolith Materials. So
okay.
Rob Hansen and team there just done an amazing job of like building a really interesting business. They're doing methane pyrolysis where they produce carbon black for car tires and simultaneously fossil, like hydrogen. They produce clean hydrogen that had no fossil CO2 emissions. And that hydrogen could be used for ammonia production and could be used for a whole bunch of other things. So that's really promising from like a decarbonizing or getting to zero emissions for ammonia and other products. That's an amazing innovation. They've been at it for a long time and they've like nailed it now. And so are really scaling up. Another is Sila Nano, Gene Berdichevsky there. They make a new silicon-based anode material for batteries. They've raised like over $1 billion and are starting to scale up production, but it'll effectively expand battery capacity by like 20-30%, which is pretty meaningful if you think about.
Oh, wow.
If you think about like car batteries and so on, just having 20 or 30% more capacity and range and so on. So yeah.
Well, what advice do you have for someone who isn't working in climate tech today, but wants to do something to help?
Yeah, there's, I guess, very tactically, if you want to go work at a climate-focused company, there are great resources like Climate Base, Climate Draft, My Climate Journey, Air Miners, like a bunch of these communities that are forming around how to kind of helping people get careers launched in climate. And there's a lot of hiring happening in the industry. So those are great places to start. I think also though, there's not enough companies, there's not enough products being built. Like it's a very thin frontier. I don't think people fully appreciate that. Like if you look at the entire size of the software industry today, the entire software industry is 500 billion a year in revenue. The profit margin, the EBITDA associated with the climate transformation is like 10 trillion. So the transformation that's underway in climate is like on the order of 10, 20 times larger, maybe 100 times larger because we're comparing revenue to profit, maybe 100 times larger than the transformation in software. So like, it doesn't have to be just concessionary do-gooderism. There is a huge economic transformation underway, and a lot of successful companies are going to be generated out of that. And the field of companies competing in each of these new areas is very slim. Like in carbon removal, for example, in terms of like real companies taking a stab at things now, like it can't be more than like 24 that are really taking a serious stab at it. You know, that's like a long dinner table. I mean, that was the experience last September. Climeworks had their conference in Switzerland, and the whole industry basically showed up, and we sat around 2 tables, and there were several representatives from each company, like the whole industry. And just when you think about that, there are many, many unexplored avenues for carbon removal. No one is really working commercially on methane removal as like one example. I mean, there are like so many areas that are just deeply underexplored in climate. And it is like the biggest economic transformation of probably a century. And so I just think there's a huge amount of opportunity there that people should be excited to go take on, either by working at an existing company or starting their own.
I love it. It's a huge opportunity. Go get it.
Exactly.
That is a very nice call to action to end on. I appreciate that. Thank you, Peter, for all your time. I learned a lot today, and it's really inspiring to hear about your mission and where you're heading. Thank you.
Thanks so much for having me.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.